Okay, so this section is the second section in chapter 3. We're starting to get into the periodic table here. And the first thing I mentioned here is the calendar. And so calendar is used to basically put days and weeks and months all together. So it like organizes things. It puts them into an order that makes sense for us. And it helps us keep track of things that way because it's in such an orderly way. So that's what the periodic table of elements is all about. It creates, there's a pattern in the elements, and the people that first began discovering and looking at these elements recognized that there's patterns that developed, and because of that created a table that organizes those patterns into specific areas. So you can kind of tell a little bit about an element just by looking where it is on the periodic table. And that's what makes it so cool. So this first guy was a Russian scientist. His name was Dmitry Mendeleev. He was the person who first developed a periodic table, and we're talking about a guy back in the like 1800s, I think, is when he first started doing this. Like late or mid 1800s, he started kind of recognizing these things. What's cool about what he did is he was even able to recognize that there's some holes in there, and so he actually predicted that certain elements would be discovered, and he was right. They found these were discovered within years of his periodic table and were placed right where he figured there'd be an element that needed to be placed. So it's pretty cool what he came up with. The only difference between what he came up with and what we use today is that his periodic table was by increasing atomic mass. Atomic mass is when we take those isotopes we mentioned in the last section, and we take all the known isotopes of a particular element, and we average their masses, which would be the protons plus the neutrons. That's where we get the mass of the atoms or the elements themselves. If we take all the known isotopes and average them together, we get the atomic mass of that particular element. And so he used increasing atomic mass. Now, certain elements have a larger number of isotopes than others, so that's not necessarily the best way to do it. We organize it a little differently now, but Mendeleev was on the right track, definitely on the right track. So he's basically known as the kind of the father of the periodic table at this point, just because he was able to start putting things in a very specific order that really is kind of what we use today, or at least that order, that idea that there's a pattern there. He first saw that and was able to kind of work with that. Okay, so the only difference about today's periodic table is we use increasing atomic number, and then the patterns of the properties also help us with this. So this allows us to put this in different columns and rows because of those patterns. But the atomic number, which I believe I mentioned before, maybe not, but we'll go over it more this section. The atomic number is the number of protons that are in the particular element. So that doesn't change. You always have the same number of protons, which is why that's the best way to organize them, is by increasing the number of protons. Because like I mentioned before, atomic mass might be a little off because the number of isotopes for some elements is different than the number of isotopes for others, so it kind of can throw things off a bit. But if we just go by the increasing number of protons, that's the best way to organize, which is what we do. Okay, so here is the element. This is when we look at the periodic table, they all come in what I call a periodic table square. It's an element square. And within that square in the periodic table, you find all sorts of information about the element itself. So it contains not only the element's atomic number, but also its chemical symbol, its name, and its atomic mass. So those 4 things are found on the periodic table. Every time you look at it, this is the information that's given to you, those 4 basic things. The chemical symbol right here, for this is iron that we're looking at, is Fe. Iron was named after ferrum, which I think was a Latin name for iron when it was first discovered. And so that's why it goes by Fe instead of like IR or something like that. The atomic number here is 26, which means that it has 26 protons in its nucleus. We also know that it has 26 electrons because the number of protons it has also equals the number of electrons that it has. But again, the atomic number is based on the number of protons. Like I said, the element symbol, the element name will be given as well, and then the atomic mass, which I mentioned before, is the average of all the known isotopes of this particular element. And so isotopes basically the mass basically takes the number of protons plus the number of neutrons. And then if there's differing number of neutrons, which means it has an isotope, we just take all of those, add them together, take the average. Okay, so here is an outline of the periodic table, just the basic outline. Doesn't go, I've got a slide that goes over the entire periodic table, but this is just an outline here that shows kind of the organization of the periodic table. As you can see, we've got some groups going across here. We call these groups, and they're the columns. The groups are, they also call them families, groups and families, kind of those are the same things. And then periods are going to be the rows across. So this is like a period is a row across, whereas a group is a column. We also have some things down below here. So these are going to be periods 6 and 7. There's a little spot in here. You can kind of see that they've taken and thrown them down below. They basically have done that to make the periodic table easier to fit on a sheet of paper instead of making it so wide. That's why that was done, for no other reason but then for that. But we can tell a little bit about the properties from the element's particular location. As we go through the periodic table in more detail, you'll see that things like this kind of start like those that all fall like in the same family or group, have some very particular properties that are similar. Same thing here. The thing about transition metals we'll talk about later, those kind of, you know, they all kind of are all the same. So we talk about 3 through 12, the families or the groups that fall in there, they kind of all hang out together and are very similar. And then starting with group 13, 14, 15, 16, 17, 18. Again, we can talk about these being back in families and having some very particular things about them that talk about their properties. So very organized in a very specific way that tells us a little bit about each of the elements. Okay, so this is a periodic table taken right out of the book. Took a couple of screenshots of it and put them side by side. This is all the known elements as of now. Now, this book was written in 2009, so there's probably a few more that are kind of up hanging out in here that have been developed in laboratories, but for the most part, these are your main groups of elements here. There's some keys up here to kind of tell you a little bit about that. So, for instance, all the blue ones are metals, the yellow ones what we call metalloids, and again, we'll get into what all that stuff is. Non-metals are the green, and then properties have not been established, or things like this. Then maybe it was created in a laboratory and haven't been able to just talk about its properties. Also here, if it's black, it's a solid. If it's purple, it's a liquid. If it's a red, it's a gas. And then not found in nature means it's going to be, I think these white ones here, the white ones here are not found in nature, which means they've been developed in laboratories and kind of kept there as well. Anyway, so we have our gases. Hydrogen is the only gas that falls on this side of the table. All the other gases kind of hang out together in this, in kind of this area here. As far as it's also a non-metal, and so non-metals mostly are going to be found on the right side. This is the only non-metal not found on the right side. And again, we talk about, it's kind of pointing out some different things. So the atomic number is the number of protons, atomic mass is that average of the isotopes. There's that zigzag line. The zigzag line basically is between the metals and the non-metals, and what falls on the zigzag line are the metalloids, which have properties of both metals and non-metals. Then we've got symbols, or the element symbol, the element name is also found there, and then we've got periods, groups, everything that we've mentioned before. And then again, there's another explanation as to why we put these two down here, just basically to make it so it's not such a wide periodic table on a sheet of paper. Okay, so this is the end of the section on the periodic table here, as far as the introduction to the periodic table. The next couple of sections will deal with specifically metals and then non-metals, which we'll go down a little bit deeper. So as you're starting to read through this, kind of start to think about an element that looks kind of like cool to you that you might want to do some more research on, because I'm going to be giving you a little bit of a project to do on an element. Nothing big, which is something kind of fun to help you like understand elements a little bit better. There is also homework on this section, and as usual, you can either print it off, take a picture of it, send it back in. You can do it on a separate sheet of paper, take a picture, send it back in. You can just complete it and send it back in. Or you can hand stuff in when you hand in stuff on the April 16th, 17th hand-in date, because that's when this is all due. All right, enjoy!